All right, let's dive into one of the most brilliant and maybe one of the most misunderstood ideas in the digital world, Bitcoin mining. We're going to see how a system can take something as basic as financial self-interest, yeah, you could call it greed, and cleverly twist it to create a global financial network that's actually secure. So how on earth does that work? Let's find out.
Okay, so let's start with the absolute core problem. In the real world, if you hand someone a $20 bill, they have it. End of story. But online, with digital money, how do you send it without a bank or PayPal in the middle to say, yep, this is real? How do you stop somebody from just, copy-pasting that digital money and spending it over and over again? This is the huge challenge that Bitcoin was built to solve.
To really get a grip on this, we're going to follow one simple payment. Our friend Alice wants to send some Bitcoin over to Bob. We're going to track that transaction from the second she hits send all the way to the point where it becomes a permanent, unchangeable part of history.
First things first, we have to understand why this whole thing isn't instant. And it really all boils down to one word: trust. So when Alice sends her payment, it gets blasted out to the entire Bitcoin network. You can kind of think of it like a message in a bottle tossed into this huge global ocean. It's out there, yeah, but it's not official yet. It's just floating around in this big pool of other unconfirmed transactions, just kind of waiting for someone to pick it up and make it legit. And that brings us to the solution, which is best described as a giant global lottery. This, my friends, is Bitcoin mining.
Yeah, this idea of a decentralized lottery is honestly the perfect way to think about it. It has nothing to do with digging in a cave with a pickaxe. Nope. It's a massive competition where millions of computers are all trying to win a prize by being the very first one to solve a really hard puzzle.
And this whole lottery thing, it's actually doing two super important jobs at once. First, the winners get to be the ones who validate all those pending transactions, like Alice's, and add them to the official record, making sure everyone follows the rules. And second, this is actually how new Bitcoins are born. It's how they're introduced into the system, almost like a central bank printing money, but it happens on a very predictable, fixed schedule.
So you might be asking, why would anyone spend millions of dollars on computers and electricity just to play this game? Well, because the prize is huge. The winner gets a big chunk of brand new Bitcoin, plus they get to collect all the little transaction fees from the payments they include in their block, like that small fee Alice attached to her payment to Bob. This right here is the incentive. It's the greed that fuels the entire system.
Okay, so how does this lottery actually work? What does it even mean to guess the winning number?
It basically goes like this. Every miner grabs a bunch of those unconfirmed transactions, including Alice's, and bundles them together. This is their lottery ticket. Then, they run this ticket through a special math problem called a hash function. All this does is it takes all that data and spits out a long, totally random-looking number. If that number happens to be low enough to meet the network's target, bingo, they win. If not, they just change a tiny piece of data on their ticket and try again, and again, and again, and again, millions, even billions of times every single second.
And when I say billions of times, I am not kidding. To give you some perspective, when the source material for this was written, the entire network was making about 168 billion trillion guesses just to find one single winning block. It's a number so big it's pretty hard to wrap your head around. It's just an unimaginable amount of computer power.
And this right here, reveals the secret sauce of the whole design. It takes a ridiculous, astronomical amount of work to find a winning block. But, and this is the key, it is incredibly, trivially easy for anyone else to check if the winner is legit. All they have to do is run the winning block through that same function just one time, and if it produces the winning number, it's valid. So super hard to create, super easy to check.
This whole concept actually has a name. It's called proof of work. The winning block itself, the thing that could only have been found through all that computational muscle, is the proof that the work was done. It's like showing up with the winning lottery ticket. The ticket itself is all the proof you need. Okay, so what does this massive global guessing game actually mean for our friend Alice and her payment to Bob?
Sooner or later, some miner somewhere in the world gets lucky. They find that winning number, and they immediately shout it out to the entire network, broadcasting their winning block. And in that block is Alice's transaction. Everyone else quickly checks it, says, yep, looks good, and just like that, her payment is no longer just floating around. It's been officially stamped into a block which gets chained onto the permanent shared ledger we call the blockchain.
This is what we call the first confirmation for Alice's transaction.
And here's the really beautiful part. The moment that block is found, every other miner in the world immediately starts trying to find the next block, building right on top of the one with Alice's payment. Every new block is another confirmation, burying her transaction deeper and deeper into this chain of history, making it more and more secure with every block that's added.
And that leads us to the final and, frankly, the most ingenious part of the whole system. How does all this hard work actually stop people from cheating? I mean, why don't miners just try to rewrite history and take money for themselves?
Well, let's think about a miner's choice. As soon as a new block is found, they have a decision to make. They can either play by the rules and start working on the next block in the chain, or they could try to be dishonest and go back to try and rewrite an old block to their own advantage.
And here is where the economics just make it all click. To be honest, a miner just has to do the work to find one new block. If they succeed, they get the whole prize, the block reward, and all the fresh transaction fees. But to be dishonest, let's say to try and undo Alice's payment, they would have to redo all the work for that previous block and then find a new block on top of it, all before the rest of the honest network finds just one. They would have to do literally twice the work for a much smaller potential prize.
And that's the genius of it. The whole system is perfectly balanced so that it is always, always more profitable to be honest and play by the rules. The enormous cost of trying to cheat makes it a completely irrational choice. The miners' own self-interest, their greed for that big prize, actually forces them to protect the network. Their greed becomes our security.
So we've seen how this incredible system works, how it turns greed into security. But it does leave us with one last really fascinating question. You see, the reward for mining new blocks, that prize, it's designed to get cut in half about every 4 years, and it will eventually shrink all the way to zero. So as that reward gets smaller and smaller, will the system stay secure? Well, that's a question the entire network is going to have to answer in the years ahead. Pretty amazing stuff to think about. That's all for this explainer.